2, 1.
Hello there, and welcome to Road to Space. We're live at the European Spaceport in French Guiana, where Europe's Ariane 6 rocket is getting ready to take to the skies. On board, we have Europe's next weather satellite, Meteosat Third Generation Imager 2, for Europe's satellite weather organization, EUMETSAT, and the European Space Agency. MTG-I2 is going to massively improve Europe's ability to monitor fast, developing and severe weather, and that is, of course, all the more important as we face increasing climate threats. We are about 16 kilometres from that pad. We're in the Mission Control Centre overlooking this glass structure, which we call the fishbowl, which is where the operational teams are focusing hard right now before launch. And I'm joined in the commentary box by Samuel Rogers from Arianespace. Samuel, thank you very much indeed for joining us.
Hi, Katie. Thank you. Hello, everyone. Great to be here with you all today.
Samuel, this is actually a bit of a first for Ariane 6, isn't it?
Yes, indeed. It's a first because we are targeting a special orbit, geostationary transfer orbit. Of course, we reached this orbit already several times with little sisters Ariane 5 or even Ariane 4. But today is indeed the first. The first for Ariane 6. Yeah.
Yeah, so very, very important. And Samuel and I are going to be with you throughout the launch today, from launch to separation of our satellite. And we've got a lot going on in the show, haven't we?
Yes, we'll see the Ariane 6 launch zone. So it's the dedicated area where the launcher final preparation occurs. It includes, of course, the launch pad that you can see on screen, but also the launcher assembly and integration building.
We'll also be seeing the teams in the Launch Control Centre, which is closer to the pad. They're all focusing very hard at this point now as we get closer to the launch. Their job very much to do with the launch zone and the rocket.
And we'll go also and discover the quick look telemetry team that you can see here. They are collecting real-time data that the launcher sends, and it allows us to continuously analyze the launcher behavior and confirm that all is as expected.
Indeed, and they'll be picking up the relay from launch onwards. And of course, we will be discovering our beautiful satellite. Right now, though, let's go back inside the fishbowl, inside the mission control room, very much the nerve centre of operations, fondly known as Jupiter, to David Cavalloles. David is the CEO of Arianespace. David, thanks very much indeed for coming to chat with us. How's it all going? How are things looking for today's launch?
Hello, Katie. Hello to everyone watching us today. Things are going extremely well here in Kourou. Our teams have completed all preparations. As we say, all indicators are green, which means that Ariane 6 is now ready to fly. And I must say that we are all very excited with this mission because for the very first time, Ariane 6 will launch a satellite into a geostationary orbit.
Yes, indeed. It's the first for Ariane 6, so it's very exciting. Hopefully it should be a beautiful launch. Tell us about our passenger, David.
For sure. Today, Ariane 6 carries on board a satellite called MTG-I2, and our client is EUMETSAT. This satellite is very special because this is a very advanced, a very complex one that will bring high value-added services to all European citizens. We can think about better weather forecasts, but also early alert in case of extreme climatic event.
So a very important satellite, but also a very important launch today for Ariane 6, the fourth one this year.
Yeah, for sure. You know, with this launch, we confirm the excellent ramp-up of Ariane 6. But beyond that, we demonstrate the very high versatility of this launcher. Basically, with Ariane 6, we can deliver any mission from low Earth orbit, telecommunication constellation, science, observation, and of course, as we'll do today, geostationary missions.
Indeed. David, thank you very much indeed. Best of luck now to all of you and the teams. Thank you, David Caballeros. So we can see there Ariane 6 standing tall on her pad, looking rather beautiful in the evening sun here at the Guiana Space Centre, with some nice fluffy clouds behind, so hopefully we should get a good view at liftoff, which is scheduled in 18 minutes and 55 seconds. Countdown on the top left of your screen. What happens after that, Samuel?
So we'll lift off towards east. As we were mentioning, we are targeting the geostationary transfer orbit that is in the equatorial plane. We will be propelled by the main stage engine at the center and the two boosters on the side. And then the boosters will be separated after 2 minutes and 15 seconds, as shown on the animation here. And then 77 seconds later, we'll have the fairing separation as the launcher will be out of the atmosphere. Then after 7 minutes and 43 seconds, the main stage will have finished its job, so we'll shut down the Vulcain engine and then we'll separate the main stage. Then 8 seconds later, we'll fire the upper stage engine, which is called Vinci engine, and it will burn for almost 14 minutes. And this is the step that will put us into the requested transfer orbit towards the geostationary orbit. Then we'll have Vinci shut down at the end of the boost. And after that, we'll have a number of maneuvers to spin down the launcher first, and then to orient it towards the right direction, and finally to generate a low spin. All of these careful steps are necessary then to be able to separate our passenger MTG-I2 as shown on screen here. And then approximately 8 minutes later, the last step of our mission will be an end-of-life maneuver. This is to decrease the launcher altitude and hence reduce its lifetime in orbit.
And once MTG-I2 is released, it's going to take about 6 months for it to go through testing and commissioning and travel to that final orbit before starting its very, very important job. We've had unprecedented heat waves and fires across Europe this summer, and people all over the world are facing increasingly extreme weather. So you don't need me to tell you that there's never been a more critical time to improve the accuracy of our forecasts and also our climate predictions. And MTG-I2 will do just that.
The weather never stands still. A storm can break in minutes. A wildfire can spread rapidly across vast areas. This is where MTG-I2 enters the story. Launching from Europe's Spaceport in French Guiana, the satellite will deliver high-resolution images of Europe and North Africa every 2.5 minutes, a rapid scan service that turns crucial moments of change into data forecasters can analyze and act upon. EUMETSAT will operate MTG-I2, enabling the observation of rapidly evolving weather events previously almost invisible, thus bringing faster nowcasting and more advanced weather forecasts.
MTG-I2 is much more than just another satellite. It's the final building block in the Meteosat Third Generation system. The more detailed our observations of the atmosphere, the better able we are to anticipate risks. MTG-I2 is another important step towards that goal. It is an investment in better forecasts and ultimately in safer and more resilient societies.
Through the Meteosat Third Generation program, Europe is building the most complex geostationary system ever launched, enabling severe weather to be tracked from the earliest signs of atmospheric instability all the way to the development of clouds and convective storms. Developed by ESA in partnership with EUMETSAT, this new generation of satellites is triggering a leap forward for weather observation from space.
Europe establishes a world-class capability for geostationary observation of meteorological variables. And those will ensure that weather forecasters, climate scientists have the data they need to provide critical information and to support everything that citizens need now and for the future.
At the heart of MTG-I2 lie two remarkable instruments. The flexible combined imager, revealing the atmosphere in unprecedented detail, and the lightning imager, constantly watching for lightning activity. Making that vision work 36,000 kilometers above Earth required the expertise of teams led by Thales Alenia Space.
MTG-I2 will complete the first family of MTG satellites and will enhance forecasting accuracy for Europe. It will significantly strengthen early warning capabilities and help better protect populations in severe weather events. Our teams at Thales Alenia Space are extremely proud to be part of this success story alongside with OHB, Leonardo and all other contributors.
With MTG-I2, some of nature's fastest evolving weather events will become visible to us sooner and in finer details. And when the atmosphere writes the next chapter, Europe will be watching from the very first line.
We certainly will, and the satellite is riding on board Europe's 9th Ariane 6 rocket. There's its Vulcan engine there that we're looking at. But the parts are built in different countries, aren't they, across Europe?
Yes, that's correct. The core stage is built in France. The upper stage on top of it is from Germany, and the boosters are from Italy and France. And at the very top of the launcher, the fairing is made in Switzerland. And all of these elements are coming together to the Spaceport in French Guiana here, where we do the final assembly.
That's right, and to bring them here, we actually use a boat. It's a rather special boat, specially designed. It's called Canopée, and it uses sails.
Yeah, indeed, it's a new kind of cargo ship. It's hybrid powered. It uses, as you said, the four sails that you can see here unfolded, and the wind to cut the emissions, to make the journey cleaner and more efficient. It also uses, in addition, a smart routing. This further helps to cut the emissions and keep Europe's launch hardware moving reliably across the Atlantic. This ship Canopée was purpose-built for Ariane 6 logistics, and at the end it means fewer delays, smoother transatlantic crossing, and more predictable delivery timelines. At the end it's key because it turns into more reliable launch campaign planning for our customers.
And that's key, isn't it, of course, for them. Oh, but also, look at that, it's a very beautiful sailing into the port here at the Spaceport in Kourou, and Canopée, of course, after the canopy of the forest. Right, well, the final countdown actually started about 9 hours ago. We're now 11 minutes and 41 seconds into that. Lots of operations during that final countdown. What have people been doing?
Yeah, lots of operation happening. It started with the removal of the mobile gantry that you can see behind the rocket here, revealing Ariane 6 on its pad. And after that, we have proceeded with flushing of the propellant lines to remove any leftover humidity. And then we had the cooling of the lines and the start of the fueling of the tank, which started around 5 hours before launch. And in parallel, we had pressurization of the different systems, electrical checks and arming, and of course getting the telemetry and the radars ready.
Nice shot there of those lightning towers on the pad. Everyone across the range inside the buildings is looking at what we call the status panels, or the panneaux d'hiver in French. There they are. Yeah, you can see them on the left-hand side there in the Mission Control Center. They're all green. We like to see green status panels. What are they actually showing us? I mean, I know they're showing us the go, no-go status.
It's a bit the giant traffic light of the whole base, and showing the status, the readiness of each of the systems necessary to make the launch happen. And we have roughly three main groups of systems. So first one is ensemble de lancement and launcher on the top, and then the second one is of course our passenger MTG-I2, and then we have a third one, the range, which includes telemetry, radars, weather, and the safety both on ground and during flight.
We had the pre-final weather check at T-20. This is now the time for the final weather check. The weather status panel has remained green, so that's good news. We are go for launch in the weather department. We're looking at some nice fluffy clouds, but some clear skies here at the Spaceport. We are on the northeastern coast of South America. A reminder that this is the Amazon rainforest we're looking at. Very beautiful, very hot, very humid, and very wet.
It can rain, it happens.
Lots of rain.
But we're not fearing really the rain. We are checking other parameters for the weather to be okay. Mainly two things we are checking. First one is the wind, both the intensity and the direction of it. We call it high altitude winds because the layer we are checking is between 10 and 20 kilometers altitude. We want to make sure that in case of launcher malfunction, the safety is okay. Of course, the launcher sustains a high wind. And then the second point we're checking is the lightning risk. On the pad, as you can see here, we have 4 giant masts protecting the launcher on the pad, but during the flight, we want to avoid that the launcher is hit by lightning. This could damage avionic equipments, for instance.
So how do you actually find out what's happening up there at altitude, and how do you test for the weather?
So there is a weather station here, and you can see the picture of it here on the screen, and they are using weather balloons carrying instruments, as you can see, that send back information about atmospheric temperature, pressure, or humidity, and completed by a number of other sensors around the launch base and the coast. They can predict what the weather conditions will be at liftoff.
Shot there of the fairing. Inside there is our satellite waiting to start its ride, and preparations for the launch actually started a couple of months ago. It's called the launch campaign. Our cameras have been following events, haven't they?
Yeah, indeed, and it started, as we mentioned before, by the arrival of Canopé ship here in French Guiana on the 14th of July, carrying the detections, the parts of Ariane 6. Smallest one is the upper stage, and the larger container is the main stage. They were transported by road here to the spaceport, then unpacked, and then they were assembled together horizontally, and this made what we call the core stage. You can see these two main and upper stage coming together. And then the core stage was transferred to the launch zone, located 800 meters away, with an automated guidance vehicle. This was done on July 31st. Then it was lifted up and placed below this mobile gantry, the giant building that is protecting the launcher while it's being prepared on the pad. And then, once ready, the 2 boosters on their side were transported to the launch zone and attached to the central core. Our passenger MTG-I2 arrived by boat in French Guiana on 12th of June. Then he was prepared during 2 months with a number of checks after transportation, as you can guess. Then he was filled with propellants on the 11th of August. You can see here the special suits we are using for that operation. On the 18th of August, we've started what we call the combined operations. Combined because it's both launcher elements and satellites. And so it was assembled to its launch adapter and then transferred to what we call the encapsulation building. It was then covered by the fairing, as you see. And 3 days ago, this satellite plus fairing assembly, what we call the upper composite, was transferred to the launch zone. It was then lifted and integrated on top of the launcher. Over the last days, we had last safety operations, the arming of the pyro systems, the pressurization of our helium systems, and today we have started the final countdown.
And the gantry, of course, that massive giant structure just behind the rocket that you can see there. Very, very impressive to see that rolling back on rails. So yeah, quite something. You can't see them very well, but on the right and left you can see the flame trenches, Samuel.
Yes, here you can see one. This is actually giant, and this is the place where the exhaust fumes will get out, and this will be the first sign of the firing of our rocket.
À tous de DDO. Attention pour la séquence finale lanceur. Top. À 0 moins 5 minutes.
So he's announced the beginning of the synchronized sequence.
Yes, indeed, and there is a lot of vital operations here that are currently running. These operations are very precisely timed, combining different checks, pressurization of the cryotanks, activation of different systems and valves, and actually the control of the operations is gradually being transferred from the ground to the computer of the rocket. It will be later the onboard computer of Ariane 6, which will actually send the command to ignite the Vulcan engine at the center of the rocket, and then the same computer 7 seconds later will check that this, you can see the nozzle of the Vulcan engine, that this engine will work properly before sending the command to ignite the 2 boosters.
Sorry, my microphone was off. We have a launch window today.
Yes, indeed, a 2.5 hours launch window, so this is comfortable, and if we need to stop for any reason, then we have time to reset the clock.
Now, excuse me, folks, a bit of a cough there. The teams watching over these operations are in launch control.
Yes, indeed, and they are the teams that are getting the launch pad and the rocket ready for liftoff. As you can see, it's a rather busy place here. They're located in a building very close to the pad, but protected, sheltered. They are sending the various commands we were talking about to the launcher to turn the launcher avionics equipment on, for instance, to fill the propellant tanks, to pressurize them, and to do all the tests step by step to confirm that the launcher is ready for launch. And in another room just behind them, behind a glass window, we have another team. Here you can see them, the engineering teams that are monitoring all these operations closely, making sure that all the parameters are as expected. They are following all parameters, but typically temperatures, pressures, or electrical currents, for instance.
Getting close, getting close now, Samuel.
Yes, indeed, and you can see the pad, and there are a number of things that you can observe just at liftoff. We can see here the yellow arms attached to the upper stage. These are the cryogenic arms filling up the tanks of the upper stage to the last moment, and at liftoff they will retract and move away from the launcher. You can see some smoke here. That's normal because we are actually topping up the upstage with very, very cold propellants. We're talking about liquid hydrogen and liquid oxygen that are minus 253 degrees for the hydrogen, minus 180 for the oxygen, so that's why they are constantly evaporating. And then it will be disconnected just at liftoff, moving away from the launcher. So that will be one part that you will see. And as we said, we'll fire first the Vulcan engine. You can see here the nozzle of the Vulcan engine, and then we'll check for 7 seconds that it's working properly before sending the command to the boosters. And once we do that, of course, we have liftoff, no holding us back. We can see as well, we could see previously the different umbilicals connecting the mast to the launcher and delivering power or air.
Getting close now to the 1 minute to launch mark. Waiting for the range operations manager to call that out.
À tous de DDO. Attention pour moins 1 minute. Top. H0 moins 1 minute.
1 minute to launch. Our very best wishes to EUMETSAT, ESA, Thales Arianespace, and everyone who's worked so hard for today.
Good luck, everyone.
À tous de DDO. Attention pour décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Top. Allumage des ESR et décollage. La propulsion est nominale. La propulsion est nominale. Le pilotage est calme. Tous les paramètres à bord sont nominaux. La propulsion est nominale.
While Ariane 6 is passing by.
Above the Guiana
Tous les
Space
paramètres à
Center.
bord sont nominaux.
The range operations manager telling us that everything is going according to plan, and we can see there we've actually got 3 engines burning. There's the engine on the main stage that we saw ignited on the ground, but we're also burning the 2 boosters, and they really are doing the heavy lifting right now, aren't they?
Yeah, they're doing most of the job. 80% of the job is done by the 2 boosters. Together also with the main engine of the main stage, they are delivering 860 tons of thrust as compared to 536 tons of mass of our launcher on the pad. So this is necessary to make it lift off quite quickly. As you see, the velocity is very, very high. And they are burning the 2 boosters 142 tons of propellant in just 2 minutes and 15 seconds.
Séparation des ESR.
And we could see here, yeah, the range operation manager has just confirmed the booster separation. We could see it from the movie. That's amazing.
Indeed, we can. We can see the 2 boosters falling away, and as you say, they've now burnt their propellant. We don't need them anymore, and we're shedding mass. We're getting lighter.
Yeah.
70%, I think.
Indeed, that's kind of lighter. Yeah.
And the range operations manager is telling us that propulsion is normal and then
Barbecue.
and he's also announced the beginning of a barbecue phase, which is the rotation to keep the temperatures nice and even.
Balanced, yeah.
And balanced. So we're looking here now, nice view on the CGI image of the fairing. The fairing is the front, the top, the tip of our rocket protecting the satellite on the ground and in space.
Yes, indeed, on ground here in French Guiana first, so from dust, of course, humidity and so on, the rain, but also, as you said, during launch, because at ignition of the boosters, it generates quite a harsh acoustic environment. And then, of course, as we cross the atmosphere, it generates friction and heat that protects that the fairing protects the satellites against. And we're just at confirmation of the fairing separation because we are now out of the Earth's atmosphere, so it's not needed anymore.
Indeed we are, and you can see that information coming in, the telemetry information on the right-hand side of your screen. We're at an altitude of 119 kilometers above our planet, which means that we're now effectively in space and we don't need the fairing anymore. So we can see our satellite, the big baby, as we have a very good image of it here now on our animation. And that's where we lifted off from the Spaceport in South America. Can you explain what we're looking?
Yeah, we're looking at the side of the satellite, and here on the right, you can see the different images that were referred to in the movie about this beauty satellite MTG-I2. Then just on the left of it, it's what we call the payload adapter, the black cone supporting it and attached to the upper stage, which is the white cylinder on the left here. And of course, below the upper stage, you have the main stage that is very, very tall. And its height here, you can see the wall of it, with on the left the Vulcan engine burning hydrogen and oxygen currently. So as I was saying, the giant stage is 32 meters tall, so it's about the half the size of the rocket, and it's rather light, 23 tons empty, but it's carrying 154 tons of propellant, so a giant couple of tanks here.
And we can see some lines along the side of the main stage. What's that?
These are feeding lines, so providing the propellants to the engine.
So a great big tank of fuel with a very thin skin to keep it as lightweight as possible.
And it burns so all of its propellant in 7 minutes and 43 seconds, so quite a fast sequence. But its role is really key because it will get us to 4.6 kilometers per second and an altitude of very close to 200 kilometers, 193.
These images that we're looking at, the visualization or an animation, the CGI or 3D as it's often known, animation of what's been planned for the flight, so they're not reflecting actual telemetry information, but the telemetry information is coming in there on the right-hand side of your screen. So the green line is the trajectory, the planned trajectory, and the yellow cross is the actual position of our rocket, and then below that we've got our altitude, 164 kilometers above Earth and climbing. Our distance from the pad in the middle there, downrange of the spaceport, and on the right-hand side, Vitesse speed, we are about travelling over 3.5 kilometers per second. That's very fast. Now, the next big moment will be switching off that main stage engine that you mentioned, Samuel.
Yes, indeed, and it will be done, so we won't send any command for switching off the engine. It will be done automatically, and this is because the onboard computer will detect that it is at the right place in orbit, the right velocity, and then it knows that it can send the command to shut down the engine. And then we'll have two other key steps: separation of the main stage, not needed anymore, and a few seconds later the firing of the upper stage engine, the Vinci.
And that's all coming up in about 20 seconds time. We will see those events. Getting a nice view there of the satellite from a different angle.
Yeah, here are the different images we were talking about.
Extinction Vulcain.
So we have that confirmed, the engine, the Vulcan engine switched off. And this is how the jettisoning looks.
Which is just confirmed by the range operation manager. We should have the Vinci ignition soon.
Acquisition par la station natale.
And he's confirming that we've picked up the signal at the tracking station in Natal in Brazil, and he's also confirmed that we have switched on the engine on the upper stage. So that's very good news. Each of these switching on and switching offs are very important. Now, we are travelling along the equator. He's telling us the propulsion is normal, so that's good. And that's because, Samuel, that MTG-I2 is going to, as we heard earlier, an orbit called geostationary orbit. We've basically got three main types of orbit. We've got low Earth orbit, which is a few hundred kilometers high, medium Earth orbit, which can be a few thousand, and then geostationary orbit, which is 36,000 kilometers away, very far away.
Yes, indeed, very far. But what's driving the need for geostationary orbit is a point that, in fact, if you look at the circular orbits around the Earth, you notice that the spacecraft travels faster when they are close to the Earth. When the orbit altitude is higher, then the speed is reduced. This was discovered by a genius, an astronomer called Johannes Kepler, at the beginning of the 17th century, and it means that when you turn that into altitude, you can find an altitude at which the spacecraft speed actually perfectly matches the rotation of the Earth. And this way, on this very orbit, the spacecraft somehow stays over the same region of the Earth, following it during its rotation. So this is very, very useful, for instance, for telecommunication broadcast over a given region you want to stay on, or as for today, for meteorological measurements or predictions.
It's incredible, isn't it, to think that Kepler, you know, in the beginning of the 1600s, he identified all of this. He defined how orbits work. But then, about 3 centuries later, the science fiction writer Arthur C. Clarke imagined a modern use for that, because in 1945, he suggested that a satellite in an equatorial orbit nearly 36,000 kilometers above Earth would appear motionless in the sky and could act as a global communications relay. I think a lot of people thought it was rather far-fetched. But actually, he was right all along, and of course, together, Kepler's physics and Clarke's imagination have given us the geostationary satellites that we rely on today. So quite something. 10 minutes and 47 seconds into our flight. On the left-hand side of your screen are the main events as they are planned to occur. You can see the next one will be the end of the Vinci upper stage burn. So the tracking stations along our flight path along the equator are collecting the information from the rocket as it flies over, and they then transfer that, they relay it to the teams here at what we call the CVI, or the Quick Look Telemetry team.
Yeah, you can see them on the screen here. They are collecting currently the real-time data which the launcher sends to these different ground tracking stations. It includes many data, but typically the status of the engine, the trajectory, the flight control, and they are comparing live this data that the rocket sends to what was predicted. This allows them to continuously analyze the launcher behavior and confirm that this is as expected. And of course, they can confirm at the end that the separation is planned, is separated, is confirmed as planned.
They have an internal comms loop, don't they?
Yeah, to the range operations manager, who then confirms the key steps and share it with all of us.
Doing a very important job there, and lots of information all coming in very quickly, so they have to really concentrate hard. So there we have our satellite, MTG-I2, attached, hurtling through space. And satellites are vital for monitoring the climate and forecasting the weather because, well, I guess it's fairly obvious, but from space you can see things and detect things that you cannot see or detect from Earth. And they send regular data day after day over long periods of time. And that helps scientists to understand the bigger picture, but also to focus in on the details, so that's very important. Now, Meteosat Third Generation satellites are a highly innovative system for Europe and Africa, and they are the latest chapter in a long partnership between EUMETSAT, the organisation in charge of managing Europe's weather satellites, and the European Space Agency. The full MTG system is made of 6 satellites. 4 of those are imagers, and 2 of those are sounders. And if you want to know more about what that means, then you're in the right place, because joining us now is Graham Mason. Graham is the Meteorological Programme Manager at the European Space Agency. And Graham, thank you very, very much indeed for coming up from the fishbowl to have a chat with us.
Thank you
Graham,
for having me.
let's just start by talking about what makes MTG-I2 so important.
Well, together with MTG-I1 and MTG-S1, which are already in orbit, MTG-I2 completes the in-orbit operational family, as we call it, of the Meteosat Third Generation satellites. The 2 imagers provide high-resolution images on 16 spectral bands, and that is with 500 meters resolution or 1 kilometer, depending on the channel, while the sounder has about 17,000 channels and allows to provide vertical profiles of the atmosphere, temperature, humidity, and so on. But this much...
Just going to just interrupt you there to say that we have acquisition at the next tracking station, so that's good to hear. Yes?
With the 2 imager satellites, it allows the 2 imagers to do different tasks. So MTG-I1 will do a full image of the whole Earth disk, which takes, for the high resolution in channels, that is about 500 million pixels.
Wow, that's a lot of pixels.
And it does that in 10 minutes. Mm-hmm. Whereas the I2 satellite will then focus on Europe, and it will do a repeat of the European area, including the Mediterranean and North Africa, every 2.5 minutes. So that will allow to track fast-evolving weather situations.
And it's got some clever instruments on board, hasn't it, to do just that?
Yes, the first instrument is the Flexible Combined Imager. That's a visible and infrared imager, and it's the world-leading geostationary imager, so beating the others in terms of performances. It is 16 spectral bands, and as I said, about 500 million pixels for it. The other instrument we have is the Lightning Imager, and that is a remarkably sophisticated instrument with 4 optical heads that continuously monitor about 80% of the, or more than 80% of the Earth's disk in a very narrow spectral band at 777 nanometers, which is where an oxygen triplet emits, particularly in lightning.
So I'm going to say that's the technical stuff. How does this actually help us to really understand what's going on, particularly at the moment we're having a lot of very extreme events? How is this going to help us?
Well, as I said, the Flexible Combined Imager and MTG-I2, it will provide rapid scans over Europe every 2.5 minutes. And that will allow to monitor these things. So just to give some examples, the infrared channels there can be used to monitor wildfires. And with an update of every 2.5 minutes of how those are evolving, that's incredibly important for tackling those and resolving the damage. The other issue, of course, is with rapidly evolving extreme weather systems, the imagers can show all that, and by combining the lightning imagery together with that can really help in identifying these rapidly moving, evolving systems before they get to extreme weather events.
Well, that's very, very important, isn't it? And very important for the emergency services as well to try and work out which way things are going and then plan and predict. So, I mean, this has been a huge collaboration of teamwork, hasn't it, Graham? And lots of different people working together to make this happen.
Yes, first of all, I have to say, I think the MTG satellites have already proven to be world-leading in terms of performances. The first MTG imager took 12 years to design, develop and build. And the second one has taken a further 4 years. So these have been done by many teams across Europe. The lead contractor has been Thales Arianespace, but it's been a consortium of over 70 companies across 18 different countries, 200 subcontracts with over 2,000 people working on this at the peak. And I have to say that developing such complex satellites has only been possible through the professionalism, dedication and fantastic teamwork between all the teams involved.
Indeed. Graham, thank you very, very much indeed for coming to talk to us about. You are absolutely right. Let's go over now to Thales Arianespace and to Olivier Brise, who is the program manager at Thales Arianespace for our satellite, MTG-I2. They have huge expertise in this field, and I think he's absolutely the right person to hear about it from.
C'est un excellent métier puisqu'en fait on est un peu comme un chef d'orchestre par rapport à une équipe qui est à gérer, à manager, à être à l'écoute surtout, à jouer une partition mais qui est connue en théorie. Dans la pratique, il y a un gros écart. La grande difficulté en tant que chef de projet, c'est de maintenir leur confiance et de maintenir leur motivation. Malgré un environnement compliqué, on est constamment en train de s'adapter et on a besoin d'une très grande flexibilité. Le projet comme Meteosat, c'est un vrai marathon. Moi, j'en ai déjà fait 14. Je dirais même que c'est une succession de marathons. À chaque fois, il y a un marathon pour l'aspect de design et de développement, un marathon pour l'intégration. On a besoin vraiment beaucoup d'endurance, de rester motivé. Aventure, grande aventure personnelle et puis grande aventure pour les équipes. Fierté, beaucoup de fierté par rapport aux résultats tels qu'on l'a obtenu. Beaucoup de respect par rapport à tout le travail qui a été fait. Les gens qui ont précédé cette aventure, beaucoup de respect pour eux. Et puis aussi, en avance de phase, beaucoup de respect pour les gens qui prendront le relais. Maintenant, c'est un gros bébé de 1,8 tonne. Une fois qu'il sera rempli, il aura une masse totale au lancement prête à 3,8 tonnes. Sa consommation n'est que de 2 kW, c'est même pas un four à micro-ondes. On lui a installé une batterie, il a 4 calculateurs à bord. Il va avoir une durée de vie de plus de 10 ans pour fournir toutes les 2 minutes 30 des images à l'ensemble des météorologues. C'est un bébé qui fait à peu près 7 mètres de haut, 2,20 mètres de large. Ça fait beaucoup d'émotion parce que c'est la dernière fois qu'on le voit et c'est quelque chose, quoi.
Oh, it's really moving seeing the emotion on his face there, seeing his satellite finally being enclosed.
Yeah, very, very touching indeed, yeah.
So during that film, we're picking up the signal at the next tracking station. That's Libreville, which is on the west coast of Africa. So it's only taken us 20 minutes to cross the Atlantic.
It's fast.
What's happening in space?
So we are still, sorry for that. We are still burning the upper stage Vinci engine. So we are getting close to the end of this burn, and this is a very key moment of the mission.
So that's coming up. The next moment, the switching off of the engine, and you can see there. Recap on the right-hand side. He's telling us everything's going well. We are at an altitude of 204 kilometers. And we're going to be climbing up to just under 3,000 kilometers. So you can see we're starting to make that climb up the hill there on the top right.
So just confirm.
He's just confirmed.
Just confirmed the extinction. So switch off of the Vinci upper stage engine. So it means that's a very important milestone. It means we have reached the target orbit today, and that all the previous steps we went through, so the boosters, the main stage, etc., were built to bring us here. So this is really important. And coming is the next steps. So there will be different maneuvers to orient the launcher and to do so to meet the requirements that were expressed to separate then MTG-I2 in the right direction.
Indeed. And Europe's Weather and Climate Satellite Agency, EUMETSAT, doesn't just fly the satellites, they also process the data that our satellite's going to be sending down. They deliver the real-time information that meteorologists use to make forecasts accurate and keep people safe. So that's very important, of course, and even more so now than ever before. We all use the daily forecast, of course, to plan our activities and our barbecues. But this summer's heat waves and wildfires show exactly why the data from EUMETSAT's fleet becomes even more crucial. They help meteorologists issue earlier warnings, which in turn, of course, helps the emergency services on the ground, as well as giving climate scientists evidence to understand how events like this are becoming even more frequent. Joining me now is Christian Bank from EUMETSAT. Christian is EUMETSAT's Program Preparation and Development Team. You head that team, Christian. Thank you so much again for coming out of the fishbowl, coming up here to chat with us. Christian, it's a very important satellite, isn't it? And understanding how the weather and climate are changing are very important. MTG-I2 are going to help us with that.
Absolutely. We're very happy that we can now complete the MTG family with this third satellite, 2 already flying, as Graham just before me mentioned. And the complement of the 3 satellites will provide us with all the necessary information that we can use, on the one hand, to monitor shortly developing weather conditions, but also in the long run, the climate evolution.
And what's so special about this particular satellite?
Now, this particular satellite adds one very important capability to the whole set. While the first imager that we launched in 2022 provides a global coverage every 15 minutes for Europe. This particular satellite now gives images every 2.5 minutes of Europe and the Mediterranean. And this is so important so that we can monitor actually the evolution of very fast extreme weather conditions, like thunderstorms or even quickly developing forest fires.
Yes, as we were hearing just now, which is hugely important, isn't it? I mean, we've seen that this summer. It's been very horrendous. So once it joins the constellation, how is the full MTG constellation going to actually change things for us in terms of improving forecasts?
Well, first of all, we're shortening the time we get the updates of the weather images with the two imaging satellites. And that is a bigger improvement over the previous generation. Then we increase the resolution. That helps to cover a wider area, especially to the north of Europe. We can now also cover Scandinavia and the Northern Atlantic, and these are very important regions which we can cover with these satellites. And the third satellite, the sounder, is providing now profiles of the atmosphere, of humidity, water vapor, temperatures, etc. So we actually have a full resolution of the atmospheric conditions. And that helps to improve weather forecasts, but also warnings for extreme weather conditions.
And you know, creating this level of advanced technology is very much a collaboration, isn't it? I mean, we're talking here about huge expertise across Europe, and at the end of the day, these are satellites and their hardware, but it's the people behind them that make them happen.
Absolutely, and it's very important to have a network of experts that can actually interpret the data and make good use of them. So on the one hand, we have very important scientific group at EUMETSAT, which provides such expertise to the weather services in our 30 member states. So the weather services collaborate very strongly with our scientific division. And on the other hand, we also support the so-called SAFs, the scientific application facilities, which are also based in the National Weather Services, which then develop very special products out of this data. So there's a huge community around this, this system that makes the best use in the exploitation of these data.
Well, today, or this year, I would say, is a very special year for EUMETSAT, isn't it? Because EUMETSAT actually is celebrating its 40th birthday. So for 40 years, for 4 decades, the satellites that you use have been powering weather forecasts. Let's take a little look now. And before we do, I want to say thank you very much indeed, Christian, for coming and talking to us.
Thank you.
Let's take a look at 40 years of EUMETSAT.
This is the story of how Europe developed a unique infrastructure to observe Earth from space, monitor weather and climate, and help protect lives, economies, and societies. In 1986, European nations come together to create EUMETSAT, turning this vision into a long-term operational system. From the very beginning, EUMETSAT draws on the Meteosat program, delivering continuous data from geostationary orbit. The organization grows steadily. With Meteosat 3 in 1988, EUMETSAT strengthens its operational capabilities and expands its network of international partners. A year later, following a US satellite failure, Meteosat 3 is repositioned over the Atlantic, a decision that proves critical in anticipating hurricanes such as Andrew. By 1990, EUMETSAT's mission expands to include climate monitoring, recognizing the importance of long-term observation to understand changes in the Earth system. 1995 marks another milestone. EUMETSAT takes over satellite operations from ESA. From its new headquarters, satellites are controlled around the clock, ensuring continuous coverage over Europe and Africa. A new phase begins. In 2002, Meteosat Second Generation enhances Europe's observation capabilities. Then, in 2006, METOP-A, Europe's first polar orbiting meteorological satellite, provides a global view of the atmosphere. Flying from pole to pole, it delivers detailed measurements of temperature, humidity, and atmospheric composition, feeding numerical weather prediction models and improving forecast accuracy days ahead. At the same time, EUMETSAT expands its role in supporting European programs through the operation of key Copernicus Sentinel missions, starting with Sentinel-3 and Sentinel-6 for ocean observation. EUMETSAT becomes a trusted global partner, fulfilling the vision of its founders. Today, a new generation is carrying this mission even further. Developed in partnership with the European Space Agency, Meteosat Third Generation, launched from 2022 onwards, enhances observations from geostationary orbit with higher resolution and more frequent imagery, alongside real-time lightning detection. In 2025, MTG-S1 and Copernicus Sentinel-4 introduce new capabilities, including three-dimensional observations of the atmosphere and continuous air quality monitoring over Europe. Meanwhile, METOP Second Generation A1, together with Copernicus Sentinel-5, strengthens global atmospheric monitoring from polar orbit, carrying 6 cutting-edge missions, including next-generation infrared sounder, EASI-NG. It delivers more precise data on temperature, humidity, and atmospheric composition. Together, these missions form a unified system dedicated to improving weather forecasting and early warnings, monitoring climate change, and helping societies adapt to its impacts. 40 years ago, EUMETSAT was an idea. Today, it is a critical infrastructure for the planet. Because behind every satellite, there is a purpose: to warn earlier, to understand better, to act faster. And in a changing world, that makes all the difference. This is EUMETSAT. Trusted in space, essential on Earth.
Trusted in space indeed, and absolutely essential on Earth. And right now, the latest satellite to join the fleet is hurtling through space, attached to what's left of our rocket, the upper stage, heading towards its delivery orbit. And as we said, it's going to geostationary orbit. That's 36,000 kilometers above our planet. But actually, the rocket's not taking it all the way there. It's going to drop it off at just under 3,000 kilometers. We call that a geotransfer orbit. And the satellite will travel the rest of the way on its own.
Yeah, indeed. Yes, correct. In fact, the orbit on which we'll separate MTG-I2 is it looks like an ellipse. It's an oval-shaped orbit. Remember Kepler we talked about earlier? He was the one who discovered at the beginning of the 17th century, again, that the planet orbits were around the sun were actually ellipses. He's saying everything is fine. So it's just as our orbit today, that is also an ellipse.
So an ellipse, I mean, you could think of it, I mean, I know you said it's an oval, but I guess you could think of it as the shape of an egg, with the yolk, the yellow part, inside the oval at one end, and then what the sort of the egg shape is the far end of the oval. And
the yolk would be the Earth.
The Earth, of course,
and
yes.
our spacecraft orbiting the Earth on that oval shape. And this oval shape has a closest point to the Earth, that is at 250 kilometers. And then the farthest point, of course, is the highest altitude we are targeting today, 36,000 kilometers. And today we'll separate MTG-I2 to an altitude just below 2,800 kilometers. And it, as you said, it will continue the journey up to 36,000. But I mean, thanks to the speed given by Ariane 6 with the previous steps we had, it will use then its own engine, the spacecraft engine, to circularize the orbit and stay at 36,000 kilometer altitude.
So it's clever stuff.
Yeah.
It's got a long journey ahead. It's going to take it about 6 months to get to its final orbit up there, and a number of different burns to get there, of course. So we're orientating ourselves, that confirmed there by the range operations manager. Whilst the early part of the launch was all about power and getting us away from the planet, and this part is all about precision and delicacy. And that's because we need to deliver the satellite onto a very specific orbit and in absolutely the right orientation. So right now, that's what's happening. The
Yeah, it's not
getting
only
ready.
exactly. It's not only getting to the right place, but also pointing the right direction. And this is the aim of all the maneuvers that we've been performing over the last minutes. So on the separation orbit here, before separating the spacecraft, the launcher is slowly doing orientation maneuver according to what the customer has expressed in terms of spacecraft orientation for separation. So this is done very smoothly. Because we want to master very precisely both the direction and the speed, because we'll have a very low spin rotation. So that's why we do it really step by step, to have it very well mastered.
And you can see actually that we are just very gently rotating at the moment.
Indeed.
To get the temperatures nice and even. So, recap there, right-hand side of your screen, our altitude. We're getting really close now, aren't we, Samuel, to our separation altitude?
Indeed.
We're at the moment, we're 2,585 kilometers high, and we're going to climb a little bit further. We're traveling an awful long way from the pad, 12,500 kilometers. And our speed, 7 kilometers per second.
And for separating the satellite, in fact, we'll kind of unfasten its safety belt, because we have what we call a clamp band maintaining the satellite attached to its to the launcher, to the adapter, to the launcher. And so we'll unfasten the clamp band, and then there is a set of springs that is used to gently push away the satellite in a very well-mastered way to ensure, of course, safe distancing without collision, but of course also mastering the distancing of everything.
Séparation MTG-I2.
And with just confirmation of MTG-I2 separation.
Confirmation that we have separated our satellite, MTG-I2. That is great news. And we're looking at some very happy faces there, Samuel, in the Mission Control Center.
Yeah.
Teams giving each other some hugs here. Everybody has worked very hard for this. These the teams there, we can see some Thales Alenia Space teams, and there's Olivier Brice, who we saw earlier, talking about his big baby.
Confirmation de la bonne séparation de MTG-I2.
And we have confirmation from the Range Operations Manager that it is the correct separation.
Indeed, yeah. But that's really a very, very good news. Congratulations to all the teams that made this happen.
So, of course, now
Look at these hugs.
lots of hugs. The job's finished for some members of the team here, but for the teams who are just taking over now, flying the new baby, they are taking on the job. It's just the beginning for them. Telespazio is taking on what we call the launch and early operations phase. So I think that's probably about the next 12 days or so. They shall be taking the satellite through its initial tests, opening its solar panels, etc. But let's go back now to David Cavaiolis, who I believe is... Yes, David, hi there, the CEO of Arianespace. David, it's all been looking really nice. We're looking at lots of very happy faces in the fishbowl, David.
Yeah, absolutely, Katie. This launch is a full success. The satellite has been perfectly injected into the right orbit, and we are delighted. My first thoughts, of course, are for our client, EUMETSAT. Thank you so much for your trust. Thank you so much for your support. I also would like to thank all our partners, the European Space Agency, the CNES, Arianespace, OHB, and all the other stakeholders. Of course, I would like to thank all the team involved. Once again, you have demonstrated that hard work, dedication and passion leads to outstanding results. Thank you so much.
It certainly does, David. Thank you very much indeed, and congratulations to you and to all the team. David, thank you. So, everybody here looking very happy. It was a very beautiful launch. We lifted off from the pad just over 40 minutes ago here at the European Spaceport in French Guiana. And I'm rather hoping we might be able to relive that launch with a replay for anybody who might have missed it. And the satellite itself is now going through its launch and early operations phase. Samuel, what's just briefly let us know what's expected.
So different steps. First, they will check that the different systems are working properly. That it will point to the sun, and then it will deploy its solar panels to get some energy from the sun to start the next phases. And as you said, it will take quite a long time to reach the final operational orbit. Testing step by step each of the systems of the spacecraft. So, as you said, this is the end of a chapter of the book, I would say, for many teams. A huge amount of work was necessary, so really congratulations to all. But then it begins the next chapter for many teams to get the spacecraft operational, and then, of course, to use it to generate very useful data.
Well, let's go now to our guests who we met earlier, and Christian Bank, the Director of Programs at EUMETSAT, who was chatting with us in the commentary box, and Graham Mason, Meteorological Program Manager at the European Space Agency, and Bertrand Denis, who is the Vice President of Observation, Science and Exploration France at Thales Arianespace. Gentlemen, thank you very much indeed for coming to the front of the fishbowl to talk to us. Christian, let's just start with you. Christian, you must be absolutely over the moon. You must be delighted.
Absolutely. I'm very, very happy in the name of EUMETSAT that we can welcome another satellite to our family of MTG satellites, now completing the constellation in orbit. So that was a wonderful ride, all very excited, but now the work for us in EUMETSAT really starts. So our colleagues in Fucino, together with Telespazio, will do the layup for the next couple of days, about 2 weeks, and then we'll start commissioning the satellite, and that will then add this satellite to our fleet. So we're very happy on behalf of our users to provide this new system, and I would like to thank ESA and industry for providing us with these wonderful satellites, and of course also to Arianespace, Ariane Group, CNES, and everybody contributing to this wonderful launch. Thank you very much.
Yes, indeed. And let's go now to the European Space Agency and Graham Mason. Graham, what a great day.
Yes, a fantastic day. I would first of all like to say many thanks to Arianespace and all their industrial teams for having safely delivered our new baby into orbit. It was a really very smooth launch campaign, a very smooth countdown, and I'm really very happy with the result. Secondly, I would like to thank all the teams in ESA, EUMETSAT, industry, who have worked, some people for more than a decade on this project, who are so happy to have this safely delivered into orbit. And it's really thanks to them, their dedication, their professionalism, that we have this wonderful satellite in orbit now.
Thanks very much, Graham, and congratulations to you as well. And Bertrand Denis from Thales Arianespace, it's been huge teamwork, hasn't it, Bertrand? And now that MTG-I2 is separated, what are the next steps for Thales Arianespace?
So first of all, it's a great step today. We extend the family of MTG with the third one, so it's due to the dedication of a full team. I take the opportunity tonight, it's late in France, but I know there is 400 people in Cannes and Toulouse to watch this session, so a warm hello to Cannes and Toulouse. So this satellite was made by industry and led by Thales Arianespace. It's a world-class satellite, so we can be proud of it. What starts now, it's a long period of commissioning, as mentioned by Christian. So we start hard work to make sure this satellite is operational.
We are confident because we did it for the I1, but it's work to be done in the coming months, and confident that we will go forward to it.
Great. Well, listen, thank you very much indeed, gentlemen. Huge congratulations to you and to everybody who has been working so hard for this today. And our thoughts now to all the teams taking on the job of taking the new baby through its first steps and also taking it to its geostationary orbit.
Congratulations to everyone also who made that day a great success. So yeah, hats off.
Yes, hats off, absolutely. It's been a beautiful launch, and we're going to be coming back to you for the next launch. But from me, Katie Haswell.
And from me, Samuel Rogez. Goodbye.
Goodbye.
Le pilotage est calme, la propulsion est nominale.
Le pilotage est calme.
The launch starts the moment you partner with us, as we go above and beyond to understand your world from orbit, everything you've ever imagined, the value you bring home to Earth, all the lives you seek to improve. So, whatever your goals, however far you want to go, your success is our mission. More than rockets, we launch ambitions. Arianespace, launching ambitions.